anymore, but it keeps doing it anyway. Because remember, this primary messenger is coming from us. If you're pooping yourself to death, you're stop releasing that primary messenger. But the cascade is still active because that G protein is still active. 100%? Yes?
Yeah.
Any other ones from the quiz? Question? Sorry, what's your question? Number one. Did anybody else worry about this one? So it says, give a situation where a solution starts off hyperosmotic but ends up being hypotonic to the cell. Include osmolarities, specify the solutes that are involved, the osmolarities, and briefly state why the solution is hypotonic. That's a bitch of a question. That's kind of not really. Because this was that strategy that I told you we have an easy way to figure this out. So basically the situation is, I'm just going to make up some numbers. So you could have just written this and said, let's say the solution starts off with an osmolarity of 0.6. The inside has an osmolarity of 0.3. So to start with, the ECF is hyperosmotic. Agreed? But what we're told is that we have to end with a solution that is hypotonic. And what that means is I need ECF to have a lower osmolarity than the ICF. Whoa. Do you guys agree with that point? Yeah. So how do I get something that starts hyperosmotic to become hypoosmotic? The key is to make the ECF solute. Do you think I want it to be able to cross or not be able to cross?
Cross.
Let's make it urea. Something that can cross. Agreed? So we started off hyperosmotic, but if we assume that this solute is actually urea, we'll end with a solution that looks like that at the end. Agreed? So this is an example where starting off with a particular osmolarity. Okay. 0.3 and 0.6. Thank you. We good? You good?
Can you do it with like two different solutes? Is that okay?
You can do it with anything, yeah. So, let's see. You mean to end up with hypotonic as well?
I mean, like, do you have to only use urea? Or can you use other examples also? Like, for example, you can use the sodium chloride in the urea. Is that okay if you use that on the list?
Yeah, so what if we did something that looked like this? So I have the same osmolarity outside versus inside, hyperosmotic. But now let's assume that that solution is made up 30% of sodium chloride, 67% of urea. What do you guys think the tonicity would be? So what would the picture look like? Give me some numbers. So the 0.3 from the beginning stays because those solutes are stuck. 0.2 from sodium chloride is stuck, and we're just left with. Is that what you're asking, Lisa?
No, I just wanted to make sure if it's okay if we use two solutes instead of.
Yeah, you can use anything as long as it is recreating that situation. Where we start off hyperosmotic, it ends up hypotonic.
Professor, is it okay if I didn't put NaCl, I put saline? Is that assumed that it would? That's
Yeah.
Oh, okay. So it's okay to put that on an exam.
Yes.
Okay.
And as a reminder, the easy way was to say if anything can cross, we just can ignore it. And the solution will be the same.
I get confused when it breaks up. So isn't it for NaCl? Isn't it 0.2 plus 0.2? Because sodium. And
Well,
then
whenever we're talking about hyperosmotic, hypoosmotic, when we're comparing osmolarities, we've already factored in whether it's going to break up or not.
Oh, okay.
So this is an osmolarity right here.
Oh, okay. So in that case, the Na would be 1 or 0.1,
Yeah,
and
so
then
this is
Cl would
already
be
broken
0.1.
up.
Okay.
Yeah.
Thank you.
Good? That's all right?
Yeah.
Can I click? Can I move? Yeah. Any questions? Suspicious. Was number 2 fine?
Yeah.